Welcome to CommercialDrones.fm, the podcast that explores the commercial drone industry, the people who power it, and the concepts that drive it. I'm your host, Ian Smith. Hey everybody, and welcome to Commercial Drones FM. I'm Ian Smith, and today I am in sunny Palo Alto at the Ford Motor Company Innovation Facility with our guest, Adi Singh, who is the principal scientist for UAV integration. Welcome to the show, Adi, and thank you so much for having me here.
Thanks, Ian. Thanks for coming around, and thanks for having me at your show.
Yeah, it's my pleasure. So first, before we get started, I know everyone's going to be interested, what is Ford doing with drones? But before we get started, I want to talk a little bit about you. What is your background and kind of, how did you get here to this amazingly gorgeous office?
Well, we weren't always this way. So I've been working in one capacity or the other at Ford since June of 2014. And before that, I was just doing my bachelor's and master's at Stanford across the street. So it wasn't really too far-fetched a possibility for me to hop the fence and join the company here. My academic background is in aeronautics and astronautics, and my focus has always been drones from a academic perspective and a hobby perspective. And when I joined Ford, it wasn't as someone who was working in drones, but someone who was working in mobility. So my boss likes to joke that I work for a car company, but I've never worked on a project to do with cars. It's always been on one of these other aspects, mobility aspects that you've mentioned in our conversations today. So I worked on bikes, which was my starting position at Ford, where we worked in the InfoCycle projects, contributing to our mobility work. I did a project which was called Riders for Health, which was a mobility project in Gambia that Ford assisted with. And then a dynamic shuttle project, which eventually coalesced and ended up with the acquisition of Chariot in San Francisco in 2016. And right about when that happened, it was a natural transition. That was about the time when Part 107 had been released. It was August of 2016. And it seemed like, and Daimler had, and just the month after Daimler released its Vision Van concept, and I think we got the sense at Ford that the industry is moving in a manner that this is yet another mode of mobility that we can explore. And who better to look at it than someone who's already been working on mobility projects?
That's really cool. And so just to kind of set the scene for those that are listening, we've got a really cool new office here. So Adi took me on a tour, super Silicon Valley feeling, like, wide open spaces, tons of whiteboards everywhere, like lots of glass and everything. But what struck me was that I have yet to see a single Ford car or truck. Like nothing. I saw a bike in the front. I've seen some of your drones over here. But yeah, there's like no Ford cars in sight. And so I think the key word here is mobility. And, it's becoming very apparent that, this facility, this group of people here at this office are kind of looking at everything, almost everything else besides automobiles themselves.
True, although I'd say that with the caveat that it's not that black and white. I can assure you there are cars and trucks and vehicles in this facility, just not out for display because they're being actively worked on. But I'd always like to remind people that we have a 100+ years history of building and manufacturing and designing cars, good cars. And ultimately, everything that we have been doing since the company was founded was moving people and goods from point A to point B. We're just expanding that scope and now using more methods than just cars to do the same. So the thesis of mobility is still the same.
So what's the plan then? The first thing that I think is, okay, Ford, we've got some drones here, some UAVs. Should we just slap some wings on a Mustang and call it a day? Now we've got a flying car, or is there another kind of play here? Like, what's the plan with this drone division? I've gotten a little brief taste of it, but maybe you can explain for the listeners a little bit more about what's happening here.
Right, that's a very good question, and I do like to whet the appetite whenever I'm pitching our drone division or our drone work. With the concept of flying cars, because it's so easily digestible, since I guess most of our generation has grown up watching Jetsons and fantasizing about Jetsons. But I think that's still a long ways away, or at least a few years away. And there's a lot of steps that we need to accomplish, a lot of hurdles that need to be crossed before we reach that area of scalable flying cars in operation. I mean, if you look at it, I think I was reading an article on the history of flying cars, and I think the first flying car concept was developed in the 1920s. So these things have been around. So in the shape of these one-off contexts, and sure, we can also build one, but what we are interested in is building a scalable thing which operates on the order of magnitude that cars now operate. And for that, a lot of these little steps need to be crossed, and starting off with these low footprint drones that are very lightweight and do something useful till we bring the society, the government, the customers, the market, the shareholders to a point where flying cars becomes a reality. You bring about change, but you can't bring about too much change at once.
So has Ford ever had a kind of any history in aviation? And I ask this because, Honda actually has a jet, the Honda jet. Honda has kind of dabbled in aviation before. Do you know if Ford has ever done anything in aviation? I mean, you manufacture so many parts of a vehicle that it could be applied to existing like manned aircraft or anything. Is there any history there that you're aware of?
That's a very good question, and it's so interesting because I find it so interesting because it's right at the crosshair of my background in aviation and my job in an automobile industry. So the short answer is yes. Ford Aerospace is all that you have to Google. And in the 50s and 60s, I'm not sure about the exact dates, Ford had a very well-functioning and expansive division looking into aerospace. And part of that had to do with World War II and the government requiring assistance with production and how the Villa Run facility was set up to aid with that. And I did hear a rumor, to which I wouldn't vouch, but it may be true, that when the initial moon landings took place, there were Ford employees in the Kennedy Center assisting with that. So we do have a history, and if you look at the automobile industry in general, not just Honda, not just Ford, but there have been other companies, big automobile companies that have been involved in aviation before. So BMW used to manufacture planes. Which is why their logo is the half blue, half white, which is a spinning white propeller against a blue.
So they went the opposite way.
They went but then Rolls-Royce actually did the other thing, which is they were so big into cars, and now that they've kind of been separated into different divisions, they focus on jet engines.
Yeah.
So since the technology is so similar, and even at the physics of it, the mechanics of the processes is so similar, the system engineering thinking is so similar, there's a lot of cross-breeding between the two fields.
Mm-hmm. Well, that's really interesting. I wasn't aware of Ford Aerospace. I'll have to check that out and Google it after this. So we mentioned earlier the transition into a mobility company, and yes, of course, there's like Ford cars here. I just haven't seen them yet, as you mentioned. And can you describe though a little bit about like what's your day-to-day here? I mean, your title is super awesome, principal scientist of UAV integration. So what do you do at Ford in the UAV division?
Right. So there's three things that I'm involved with. The easiest one is the technical stream, right? Which is actually getting the drones into our vehicles, getting the drones into the mobility ecosystem, building innovation acceleration tools, building concepts, inventing innovations around, inventing concepts around the area of flight, which could be useful for Ford. To which end our lab facility aids us a lot. The second is the policy aspect of it, which is interfacing with government entities, interfacing with the FAA, and not just in the US, but in EU as well, to make sure that we have a pulse on how the industry is shaping up, because we want to inform our strategy according to how the government and the operational framework for UAVs will be in 2 years from now and not what it is right now.
Yeah.
Right. And to that end, we are very actively involved with working with the FAA. And the third aspect to that is, or to my work, is the strategy side of things, which is to ensure that we're always looking at the big picture. There's a product development roadmap in place. We have University Alliance resources that are allocated to the right projects and have deliverables that make strategic sense to the business. So yeah, all three of those come together and define my responsibilities in my work.
You mentioned the regulatory part of it. So during my habitual LinkedIn stalking for guests prior to the interviews. Yeah, I do. No, and I know there's a setting where you can turn it off, but I don't care. I want people to know. Ian Smith has viewed your profile. You were a member of the ARC, so the Aviation Rulemaking Committee, specifically for the integration of unmanned aerial systems into the national airspace in 2017. So what were your duties there? What were you guys working on? And why is Ford, again, interested in this? I think I'm going to continue asking this, question on why is Ford interested in this to just kind of give an idea and help myself and all the listeners too to understand, are we going to be flying around and flying Ford cars maybe in 20 years? But
quite a possibility, and I will definitely not reject that possibility. It's just I will always temper it by saying we're not there yet as an industry, as a market, but we are making our headway. So, taking a step back about why Ford is interested, that is definitely the first question I'm asked for the last 2 years whenever I talk about my job at, in a private meeting or in a public forum. So last month I did something, I front-loaded the conversation. I sat on a panel at the FAA symposium, and while I was introducing myself, I said, I know all of you are wondering right now what Ford is doing here, so let me just clarify that now so we can go to the crux of the discussion. And the answer is we are a mobility company. We are focused on mobility efforts. We have acquired startups to pursue those efforts. We have made strategic investments, and this is just one aspect of that investment and of that effort in bringing together this holistic multimodal ecosystem. So for me, but maybe it's because I've been here long enough. For me, it's a very natural an organic section of what Ford is doing. But I do understand that there is this huge legacy that Ford brings to the table. And it's hard to think of it in a different way, especially because, at least at this point, not a lot of car companies have come into the public and really made themselves known. You've seen these one-off concepts and demonstrations and prototypes, but not really getting their hands dirty. So,
and an example of one of those, and we'll get back to the ARC question in a second, but an example, of course, is Mercedes-Benz with Matternet. I mean, they're partnered together, but you don't see Mercedes-Benz drone division people, UAV division people at attendance or speaking at any of these events or being involved in anything with the FAA or any other kind of public-facing activities that I'm aware of. So that's a good point. So I think that's why it's so interesting too. And I only saw your name start popping up probably like last year, 2017, during the ARC thing. I was like, okay, interesting. Ford has a representative there. So something I needed to pay attention to.
It's one of those quirky things that was actually a bragging point for us. We were the only automotive company to participate in the ARC, not just the ARC, but the FAA, but working closely with the FAA on drones. So not only were we representing ourselves, we were representing the automotive industry.
Mm-hmm. So remote ID and the ARC. So I know that's what you were involved in. So the Aviation Rulemaking Committee. So finally, back to that question. So what was going on there? And you guys are bringing some expertise. Ford is not a stranger to large regulation on moving vehicles at scale. So there's a bunch of challenges with that. And just tell us a little bit about the ARC and your involvement there and remote ID. I think that ties in very nicely with it.
Right. I think it's a very relevant question, especially given the state of the commercial drone industry right now. The FAA has essentially realized that we need a robust system of identification going on implemented for drones across the national airspace for these objects to be governed. because without governance, there's a lot of, how are you going to discriminate a threat from legitimate use? And to that end, there's a lot of phobia in the public about the way drones can be used. And their reputation isn't exactly very positive when you just speak to a layman walking down the street. So having a robust system of identification and tracking to hold the user accountable for their actions, for their use of the drones, is essential for any other governance to take place. There's no point in creating legislation and creating rules when you can't even correlate a drone equipment to the person who is using it. Right? So you can say you can't fly in a particular place, but if you can't even identify who is doing it unless you're able to see them, no point. So very relevant, and essentially the groundwork for any other legislation and rulemaking to take place. I like to make this analogy that this is analogous to a license plate system for cars, right? It is the most essential part in the whole chain of holding people accountable for their actions. You note down a license plate number, and you report it.
What happens if you're driving around without a license plate?
Right, you get pulled over, right? So,
yeah.
but the story doesn't end there, right? What my team wanted to do was essentially understand what was the logic behind the various. At its face value, it's very simple. Okay, just slap on a number on a car and you identify it. But what are the characteristics of implementing such an identification system? You're making the identification known to anyone in public, anyone who looks at the car. I'm just going to focus on the car for now. Right?
Yeah.
So that's one. So anyone can report your vehicle if a concern is raised. It holds yourself accountable because you know psychologically that someone else can view your vehicle and identify your vehicle and report it, which is the second part. Just by knowing the car's identification number or license plate number, you are not able to track down the driver. Like for that, you have to go through a process, and in a lot of cases, those processes and the PII is limited to the authorities, right? To the DMV and to the police and whatsoever. So that's another characteristic. Publicly visible license plate system, but the PII is still protected in a system, in a framework that is governed by accessible to the authorities on a case-by-case basis.
And PII being personally identifiable information.
I'm sorry for
no
abbreviation. So,
no problem.
Yes, personally identifiable information, right? So because privacy is a huge concern whenever you're talking about identifying and tracking things. It's always a balance between law enforcement would love to track and identify everything, right? But then there's also the privacy and security concerns of not turning our society into some Orwellian version of itself, right? So there's a balance that needs to be struck, and we published a white paper together with the blog post that we referred to last month, which coincided with the FAA symposium also, in which we broke down not just the technical solution which we presented at the ARC and was considered at the ARC and eventually included in the ARC's final recommendation report, but the reasons behind creating a framework as such, right? The scalability of it, the acceptability of it, the privacy consideration of it, and also catering to the needs of law enforcement adequately.
This episode of Commercial Drones FM is brought to you by FLIR. Pretty much everyone in the commercial drone world knows about FLIR's thermal imaging technologies and may even have a basic understanding of how their sensors work. At Commercial Drones FM, we think this technology is deserving of the spotlight to reveal some of the incredible things thermal imaging drones can accomplish. Drones equipped with thermal imagers offer a way to see the world from a different perspective, which can help identify infrastructure problems, locate missing people, and increase safety and efficiency across a variety of industries. The value of thermal imaging for commercial drone operations is undeniable. So I want to use this podcast as a platform to dive deep into the world of heat and seek out the best practices and the unique use cases that make thermal imaging sensors the most drone-ready payload for commercial drone applications right next to RGB cameras. So join us over the coming months as we invite FLIR and their customers into our studio to discuss the technical and practical uses of their groundbreaking efforts in aerial thermal imagery. This episode of Commercial Drones FM is brought to you by Deveron UAS. Deveron UAS offers enterprise drone services for farmland across North America. I recently spoke with Bonduelle, one of Deveron's largest customers.
So my name is Jennifer Thompson. I work for Bonduelle America's Long Life. We're a vegetable processor. Bonduelle is a very large company with 54 plants in the world. Here in North America, we have 11 plants doing frozen and canned vegetables.
So naturally, I wanted to know, how is Deveron helping one of the largest vegetable processors in the world by using drone technology?
So we use Deveron to service and support our precision agricultural needs. For us, it's not easy to have our own or fly our own drones to gather crop data. So Deveron is ready and available to work for us when needed. We fly thousands of acres, and managing those acres, it just works very easily with them in our fast-paced growing season. They're not just providing data, they're helping to solve issues and find solutions.
Well, that's very important work, but what's your favorite crop to eat?
My favorite crop to eat is sweet corn. I will eat sweet corn 365 days of the year.
I'm not sure if I've ever eaten sweet corn yet that was monitored by drone. To learn more, visit deveronuas.com/dronesfm and see for yourself how Deveron is leading collaboration in agriculture with drones. That's deveronuas.com/dronesfm. Okay, back to the show. So, and I want to call out this blog post. So we've been referencing it a few times, and I just looked it up here on my computer. So I've got a URL to share. It's just medium.com. So the blog platform, medium.com/City of Tomorrow. And I believe that is the Ford Motor Company's blog there. And so if you just type in Ford drones, you can see this blog post we're referring to. And with that said, we have a drone sitting here as well. And so in that blog post, you guys mention that you've come up with some technology to help with this remote ID problem. So can you share a little bit about like how that works? What was the technology you guys came up with? It was like super simple. I think one of the benefits was that it was like zero cost. Like the capabilities are already on these drones. Maybe you can elaborate a little bit.
Yes. And the solution and the white paper and the ARC's recommendation report and the analysis of all the 7 solutions included there, it's all public. So anyone who's interested can definitely delve into that and consider and add to that, essentially, which was the idea of this whole endeavor, right? Which is to contribute to the industry in a positive manner and not just do our little thing in our little labs.
Yeah.
So the solution that we came up with was based on visual light communication, visible light communication, and which was one method which we figured out could use the anti-collision lights on a drone, which are normally mandatory for any nighttime operations. And since nighttime operations are fairly popular, in fact, 90% of the Part 107 waivers are concerning nighttime operations. A lot of drones automatically come with that inherent capability of beaming a light within a certain distance that is required by Part 107. I think it's 3 statute miles.
Yeah, I don't know that many drones that don't have. I mean, some of the do-it-yourself drones, those don't really. You have to add on your lights, your positioning lights, your anti-collision lights yourselves. But most of the popular ones that you can buy out of the box, have those already.
Yes, exactly, and that's a safety mechanism, right? But our problem statement was: can we use an existing component of the drone to also cater to the identification? So we came up with a simple solution where a software library uploaded to your microcontroller or your flight controller would blink these anti-collision lights very fast, too fast for you to even notice that anything is blinking. But
for the human eye to
understand, to see if anything is blinking, the power output obviously averages out, which means you'd see them slightly dimmed, but not significantly dimmed. But if you held up a smartphone, which is our way of putting the identification mechanism in everyone's hands and not just some people with special equipment to beam into it. If you put your smartphone, there's a computer vision based app which we trained with convolutional neural networks to identify various drone shapes and then zero in on the lighting solution, on the lighting aspect of it, and then see which lights were actually blinking, because those are the ones you're interested in. And you already know these frame rates, so you can sync that system and look exactly for those lights. And when you look at that data, those blinks are essentially a binary system, which is continuously beaming your FAA registration number.
Wow.
Right?
So
and guess what? Once the FAA registration is known to you, you still don't know who the person is, but you can report to the authorities, similar to a license plate. Yeah, the lessons you learn from the car industry. And then the FAA's registration database, assuming you are flying under Part 107, already has all your contact and identification details and PII.
Very, very interesting. Okay. And so what's the status with this? Like, you said that this is all available publicly. I mean, do you feel that this might be something that could be, I don't want to say like a regulation that's put in place or a policy, but like, what do you feel like that? I mean, it sounds like you guys thought about this a lot. You delved into it, you developed a solution, you showed that it works, you created the mobile apps and everything. Like, how much does that actually help? How real do you think this is? Do you think it's just kind of, a supporting piece of evidence that this could be a possibility? And, it's such a hot issue as remote ID. As drones continue to be in the skies, you've got the hobbyists who are trying to protect their hobby with the Part 336, or I don't know if the numbers are all jumbled in my head, but yeah, like what is this? Yeah, Section 336. So what does this bring to the conversation? And is this like the best final solution, do you think? Or, we've got ADS-B that's a potential solution. What's going on here, and what's the state of affairs?
Mm-hmm. So I always shy away from black and white answer. I don't think any solution out there is the best solution, which is why after 4 months of deliberation, there were 7 solutions included in the AUK's final recommendation.
Oh, so that's just one of the solutions.
So ours is one solution. I think out of 50 plus that were submitted for consideration across the industry, which was the a brunt of the work that was done by one of the working groups, and then there's a lot of system engineering analysis, matrix analysis, SWOT analysis, debate, lots of debate as to what is possible and what's good and what's feasible. And ADS-B, like you mentioned, is also one of those. ADS-B is definitely one of those solutions, and Wi-Fi based 802.11 is another solution, so on and so forth, right? What I like to think of it is that each of these solutions cater to a different class of operations, and perhaps a different level of security is satisfied by increasing levels of complexity and increasing level of equipment. This solution is on the extreme end of the spectrum, where you're looking at low-cost solutions for near-range operations. If you consider the ambient noise during daytime operations, this solution would likely can operate reliably at about within about an 80 to 100 feet range. Mm-hmm. But in our view, if I'm concerned with privacy and I see a drone flying around, a little speck that is flying 400 feet away from me, I probably won't even notice and it wouldn't bother me.
Yeah.
But if something is flying right in front of my face or very close to me, that's when I start getting interesting, I start getting curious, and I start getting concerned. That is when I want it to be recognized, right?
Yeah.
But of course, the DoD can come and say, or another safety organization can come and say that, but we want to know who's flying that little speck as well, because this is protected airspace. And for those cases, you can have more advanced equipment. You can have ADS-B, you can have Wi-Fi, you can have satellite communication if you want. But keep in mind, with each of these additional equipages, you increase the cost of compliance, and that's a barrier to entry.
Yeah.
When we were creating this, we were considering not just the privacy of the user, but also how easy it is for a hobbyist to comply with it. And if you're going to say that on a 200 maker, $200 drone that you hack together, you need a $500 piece of equipment for compliance, it doesn't make sense. But if we say there's a software library, maybe you spend a couple of dollars, get some bright lights, you already make a safety case. It actually helps you orient your drones as well.
Yeah, exactly.
That's where, that's the kind of spectrum that we work with. So, in my discussion on the sideline of the ARC, I definitely see the recommendation that there has to be there will be no single solution available, right? It has to be based on the class of operation, the type of operation you're doing, and the requirements of safety that you need to satisfy for that operation.
It's always been risk-based. I mean, wherever it poses a risk was, for the Part 107 regulations as well, and beyond visual line of sight, and the weight of the drone, so this is like the proximity of the drone and the type of operation. So it makes sense. It's a tough problem to crack. I really like the ingenuity that you guys showed in developing this. I think that could just be one of the layers, one of the many potential layers that are used for remote identification. And so,
and let me just add something there, because an interesting development came to my notice this week, where the French aviation authorities, and I was sharing this with my team earlier today, the French aviation authorities came up with a proposal, or at least a show of intention. I don't think there has been any legislation around it, about identification of drones. So all these governments are interested in identifying the drones flying in their airspace, and they have a two-part solution. One is a Wi-Fi, and one is a light beacon flashing a Morse code, which sounds strangely familiar to something we came up with.
It does indeed.
A time back. So, it's more of a pat on the back for me to see that we're kind of thinking ahead of the times and really helping out the industry see things in a different light.
So this drone that we have here, this was really cool when you mentioned this to me as well. So we've got a drone sitting on the table. To be honest, it's kind of looks like a little bit of a Tonka toy, like brightly colored, but it's very like approachable. It's 3D printed. It's like, a total DIY drone. I don't see a lot of these days. But what you mentioned about it which was super cool, is that I think you were saying, you want to kind of promote anybody in this office. So not everyone here is working on drones. You've got people working on airbags and different things that I saw just when I'm walking around. If they have an idea, in this kind of like think tank, in this creative collaborative environment that you have going on here, you want them to be able to easily prototype that on the drone. So tell us a little bit about this drone, this DIY little philosophy that you guys have here for your UAV division.
Right. Wonderful. So there's so much to talk about it. I'm not sure exactly where to start, but let's see. We call this whole project the breadboard drone, and it is
the
essentially
breadboard drone.
Yeah, it's essentially a development platform, which is why it looks such a DIY Tonka toy.
No disrespect, of course.
No, that's fine. No. That's almost a compliment, actually. So we wanted to create something for the people at Ford, for the engineers at Ford, who had a lot of ideas and concepts they wanted to test out, and inventions they wanted to prove on drones while they were working, but they did not have a understanding of how to actually build a drone, how to set up a drone, how to program the flight controller. There's a special capability that you might have, but it may not be building that drone. So what we do is consider it what a software framework does for you. It does all the nitty-gritty, boring grunt work for you, so you can build on top of that and add and focus on what the software community calls the business logic, right? So just the novelty that you bring to the application, instead of setting up your servers and scaling them, and the cloud architecture and the communication and the data pipelines whatsoever. So consider this a hardware, software, electrical version of that framework, which provides a way to accelerate development. So to give you a quick example, you mentioned airbags earlier, and someone in airbags wants to slap on a modified version of an airbag, or wants to design an airbag for drones, or has some idea where they could bring their capability to drones, but they do not know how to build a drone. They can start off with this library that we have shared with them. It's internal to Ford right now.
By library, you mean like literally this drone right here? It's a
GitHub repository that we've shared across Ford.
Okay.
That's accessible. It has all the CAD files, it has all the firmware, it has all the tutorials and the instructions of how to set things up.
And then they can just go ahead and just...
Exactly. Okay. So someone in Australia, in airbags, wants to test something out. All they need is a 3D printer and order the parts. But it gives them something to start off with. From there, you can change things. Everything is parameterized. So if you want to do a configuration where you want 8 arms instead of 4, very easily done.
Yeah.
If you want to miniaturize it all, very easily done. If you want to, change one of the aspects in a CAD module and in a CAD software and slap on an airbag so that it accommodates an airbag, very easily done. We in fact used this platform last year to test various sorts of landing leg designs, because some of our landings aren't exactly smooth. So in the case of rough landings, what is the best absorbing mechanism while also keeping cost and ease of production into consideration? So what you see here is a little different from what you might see on the blog post, because it's gone through some iterations of what are the best.
The legs are totally different.
Shock absorbing mechanisms. Just to give you an example, the sky is the limit once you have an innovation acceleration tool like this at your disposal, and then you can modify it however you like.
So you guys are kind of democratizing drone innovation within Ford. That's really cool.
Yeah, and just like how Drone Code is doing this for the industry, and as I in our discussions earlier, we are using part of Drone Code components like the PX4 stack and Q ground control station, so on and so forth, to build on that, because we do want to build on the shoulder of giants, but then we also want to lend a shoulder for others to build upon.
Adi, you were quoted in CNN Technology, I believe, as saying, as drone adoption accelerates, we think many of our customers will want to use these devices as part of their lifestyle, whether to pursue hobbies or even as a tool for their business. So with that in mind, can you give us a little taste, maybe if we're looking out 5 years from now, what do we what kind of things could we potentially see from Ford, or where do you see your division moving forward and getting some traction for the drone industry as a whole in that kind of 5-year time frame?
Right. I have to be careful with that question, not because I don't want to share the information, but because I likely don't know that information, right? 5 years is so far ahead to see, but when we are discussing our business priorities, one thing we've made certain is that we have a lot of momentum around any mode of mobility that shows business potential. Ultimately, yes, we do tinker with our toys and build a lot of cool stuff and have fun, but we are a business, and everything needs to have a business case behind it. So, my statement with CNN, is kind of gives away the kind of consumers we are looking at. You can look at the hobby consumers where an individual might want a drone in their car to capture a photograph or a video snippet of them doing something cool.
New Bronco, maybe it comes,
Exactly.
2022 model comes with a drone in the back. That would be pretty cool.
And what do you do with vehicles like Bronco and Raptors?
You have adventures.
Yeah, exactly. You take them off-roading, and you do want to capture some of these nice moments where you're doing some cool stuff and maybe climbing some low key mountains or whatnot.
Yeah.
Right? So that's one. Commercial operations is definitely another side of it, and I think our applications, there's nothing novel in the markets we are going to look at, right? Agriculture could be one of them, where you look at and monitor the health of your vegetation and your crops over large tracts of land. Package delivery is another big thing that's coming up, and again, something that's very easily digestible for people to understand. Oh, drone carries my pizza from point A to point B instead of a car. So I think the applications aren't exactly something where the novelty lies. It's in the implementation of that.
Yeah.
And I think from whatever I've told you about our work with the breadboard drone and the visible light communication and whatnot, implementation is something we focus, I think, about 90% of our efforts on.
Mm-hmm. So, I mean, I can imagine, though, and just kind of wrapping this up here, you guys have a huge commercial. I mean, okay, so if you just think of, I don't know, police cars in any city in the world, pick a city, or, work trucks for specific utility companies or something. You guys sell a ton of commercial vehicles, and that's a huge part of your business. So there's no reason why you couldn't, bundle in some drones with that as well, kind of riffing on the, hey, maybe my Bronco or my Ford Raptor comes with a drone to kind of film me while I'm doing this cool stuff. So I'm super, super interested, and I'm going to be keeping a very close eye on you guys. I think you're going to be, are you going to be at Exponential? Well, coming up, I guess by the time this airs, Exponential will probably be over, but what about the Commercial UAV Expo in Las Vegas?
Yes, we likely have, even if it's not me, we likely have representatives from our team at all these big events.
Excellent. Cool. Well, we'll be watching you. Thank you so much again for having me, Adi, at Ford here. If you want, you can get in touch with Adi on LinkedIn. Just search for Adi Singh, Singh, at Ford, and boom, he said he gets some great contacts there. And while you're at it, if you want to follow the podcast on Twitter or something, it's at Drones Podcast or Facebook.com/Drones Podcast. And hit me up on LinkedIn. Why not? Ian Smith, search for me. Commercial Drones FM is the company. So thank you everybody for listening. And Adi, thank you again for having me at this awesome, very cool, collaborative Silicon Valley arm of Ford.
Thank you very much, Ian.
All right, everybody, we're cutting off the mics. Fly safe. Cheers.